Okay, so here is a tutorial for how to get started on the scaling calculator. First, I want to show you exactly how it works so you can understand the premise behind it, and then I'll get into showing you how you can begin coding it. So the overall concept is here. We have three main sections. We have the actual measurements of these various planets and their distances from the sun, and we also have the planet diameters right over here. This information is presented in astronomical units and kilometers and in miles as well. Table 3 is an interesting table. This is going to be the place where you interact with the model when it's all done. I'll come back to this in a little bit. Table 5 and Table 6 are our model measurements. So Table 5 is all about the distance from the sun at different scales. So this information is presented in terms of how many centimeters, feet, yards, and miles each planet would be from the sun given the size of your model. Same thing with Table 6. This is going to present how big your model planets would be in different scales. How big would it be in centimeters, millimeters, inches, and feet? So for example, let's say that we set our globe, our Earth, to 30 centimeters. This is about your standard size globe in a classroom. When you do this, all this information gets updated. Table 4 is the ratio between your Earth's actual diameter, which is this information right here in F11, and the diameter of your model size Earth. And so what's this saying is that the actual Earth is 425.2 times bigger than your model Earth. If we were to make this even smaller, if we were to make this, which is 1 centimeter, if we were to make this 1 centimeter, then our ratio would be even bigger. So let's go back to a size of a globe. When you input the size of the globe, all of your model measurements get updated using this ratio. So basically what this is saying is that if your Earth was the size of 30 centimeters in diameter, a standard size globe, then Mercury would be about 0.85 miles away, which is the same thing as 1,500 yards, which is the same thing as 4,500 feet, and this many centimeters. This information is presented for all the planets. So Earth would be about 2.19 miles away, Jupiter would be about 11 miles away. And then Table 6 will give how big that planet would be. So if your Earth was the size of a globe, that means that Mercury would be about 4.5 inches in diameter, and Venus would be about 11 inches in diameter. Um, Jupiter or Saturn would be about 111 inches in diameter, or about 9 feet. So you can get these various sizes. So now that you understand what the globe is actually, or what the model is doing, let's get you started on how this might work. Here we have we'll get started. This is something that's been priorly filled out, and I want to show you some examples. Oh, let's see. Let's just get this started here. All right. This information is all presented in the instructions in the PDF file that's posted on the Google Classroom. So right here we have all of our planets in the correct order from the starting at the sun and then going out to Neptune. And we also have how far they are away in terms of astronomical units. So what this is Earth is one astronomical unit, and then all the others are relative to that distance. So we're going to convert this information into kilometers. And the way you do that is we type in equals, because we're going to have a formula or code, and we're going to reference the cell right to the left. So we're going to reference this cell, which is C9. So this equals C9 times 150 million, because there are 150 million kilometers in one astronomical unit. We're going to come down to Venus, and we're going to do the same thing, but instead of referencing this cell, C9, we're going to reference this cell, which is C10. So we're going to say this equals C10 times 150 million. And then this one, let's do Earth one more time. So if you can see the pattern, this is C9 times 150 million, C10 times 150 million. This one is going to be equals C11 times 150 million. And so you can keep doing that all the way down to fill out the rest of these distances. So next, let's go to our planet diameters. So what we want to do is convert, all this information is given to you in terms of kilometers. And what we want to do is convert this information into miles. Hold on. All right, so to do that, we're just going to reference the information in this cell and divide it by 1.60934, because 1 mile equals 1.60934 kilometers. So this equals F8 divided by 1.60934. And there you go. 1.391 million kilometers is the same thing as 864,000 miles. So let's change Mercury's distance. This equals F9 divided by 1.60934. And then this one, Venus, that's going to equal F10 divided by 1.60934. And so you get the idea. You're just going to continue that trend all the way down. So right here, we're going to put 1 in there. Okay, so in our model, we're gonna start off building our model so that it's just 1 centimeter in size, but we can change that once the model is completed. In this column right here, in this pattern, in this part, we're going to calculate the ratio between our actual measurements and our model measurements. So to do that, we're going to type in the formula. This equals F11, which is our Earth diameter, divided by I11, which is our model diameter. And that is going to serve as a ratio. When you change this number, that number will get updated. All right, let's keep it at 1. So let's go to Mercury. To do Mercury, what we want to do is we want to set this equal to Mercury's. So table 5 is about changing the distance from the planets. So Mercury's distance is 58 million kilometers. So we're going to reference that number, which is D9, and we're going to divide it by our ratio, K11. So D9 divided by K11 will give how far away Mercury is from the sun in terms of centimeters. Now we want to convert that into feet. So we're going to reference this cell and convert it into feet. This equals M9 divided by 30.48, because that's the conversion factors to go from centimeters to feet. Now we're going to convert to yards. This equals N9 divided by 3, because there are 3 feet in every yard. And then lastly, we'll convert to miles. This equals 09 divided by 1,760, because there are 1,760 yards in a mile. And boom, there you go. Now you have Mercury's distance from the sun at various scales. And again, if you change the size of your plan model Earth, all that information will be updated. All right, so as you can imagine, all this formula will be the exact same for Venus, except instead of referencing cells in the 9th row, you'll reference cells in the 10th row. So instead of writing D9 divided by K11, you'll write this equals D10 divided by K11. And this will be, instead of being M9 divided by 30.48, this will equal M10 divided by 30.48. So you should get the idea there. And then lastly, let's do this column, this table over here. We're going to change the diameter of our size. So this is going to equal, we're going to start with the sun. This equals F8 divided by K11. And then we're going to convert centimeters to millimeters by multiplying that by 10. This equals R8 times 10. And then we're going to convert to inches. This equals R8 times 0.393701. And then we're going to convert to feet. This equals R8 divided by 12. And there you go. And then again, you're going to convert everything. You're going to update all of this. Instead of F8 divided by K11, this will equal F9 divided by K11. This will equal R9 divided by K11. Oops. Equals.
But you want to do one more song? But it's a lot better. But they can
Oops. Divided by 10 times 10. Sorry.
So that's that.
And then, so you're just going to be kind of changing these things and updating them and looking at the patterns to fill in the rest of the table. Okay, if you have any more questions, let me know. Hopefully you can see the patterns and how this gets filled out and be able to complete it on your own. Thanks for watching.